Hello students, in this lesson let us study about some more tests which will be conducted on the lime. So the test we will be studying here will be the volume yield of quicklime, transverse strength test, compression or compressive strength test, and the chemical analysis. So let's get started and discuss one by one. So the 10th one is the volume yield of quicklime test. Now this is done according to the IS 6932 part 6. Now the equipment which we use here is the Southard viscometer. Okay, generally using this Southard viscometer, what we do is adjust the consistency of the lime putty whichever is there. So what we do is we take sufficient quantity of putty and fill it in a cloth, filter cloth, and we make sure that we convert this cloth in the form of a bag. Then what we do is we will subtend this bag with the help of a cord onto one vessel. So basically what we do is we allow the putty to drain away all the water which is present in the mixture. We have to adjust the consistency of the putty in such a way that it should give us a slump which is equal to 13 mm. So this is a standard which we follow for this particular test. Then we will calculate the density of the putty. So generally we will calculate the density of putty by determining what? The weight of the known volume of the putty. By weighing a known volume of this putty, and this way we do it in the density vessel. So your volume in ml per gram of the quicklime is given by 0.70 by d minus 1, where d is the density of the lime putty. So this is how we conduct the volume yield of the quicklime, wherein we see how much of volume has been yielded. Next test is the transverse strength test. So what we do in this is we will take 6 specimens for the test, and the size of this specimen will be 25 into 25 into 100 mm. Okay, now these are generally made of the standard lime sand mortar. Why do we call it as a standard lime sand mortar is because we will use the standard sand for preparing this, and either we will take hydrated lime or the quick lime in order to prepare this mix. Okay, and also the ratio what we use is 1:3. What we do is we will take the filler mold or fill the mold which is there present with us, and we will put two base plates on it, one on the top and one on the bottom, and we will cure this for about 28 days at 90% humidity. So 90% of it should be always in water. Okay. Then what we do after we do this curing, we will immerse the entire specimen in water for about 30 minutes, and then we take it out and place it between the two parallel rollers like this. Say we have, okay, these parallel rollers will be about 80 apart, and we start applying the load on this particular rollers. Now how is this load applied is, generally we take up uniformly increasing load. We will start at a 0 and go on increasing at a rate of 150 Newton per minute through a third roller which will be there. So say this is your first roller, this is your second roller, and this is your third roller, which will come in between the two rollers so that it will form a break in the specimen. Till that particular point we have to go on increasing the load. Okay. Now once we do this, we can calculate the modulus of rupture of the test specimen. Now how do we calculate it? We calculate it by small m, which is equal to 3ws by 2bd square. This can also be taken as 0.00768 W. Now we have to understand what are all these values. So in this, the M is modulus of rupture of the test specimen, generally given in Newton per mm square. W is the braking load. We will see where exactly the brake is happening, and that load we will note down while doing the test, and this is generally taken in Newton. Then here S is the spacing between the rollers. Already I mentioned that the spacing will be 80 We have to maintain the spacing of 80 and small b and small d are nothing but the width and depth of specimen. So generally each will be of 25 mm. Okay, so the minimum value of M, or the modulus of rupture, that should be there for a class A lime is about 1.05 Newton per mm square, and if it is a class B lime, then this value will be in the range of 0.7 Newton per mm square. Remember that this is the minimum value of rupture what we can have. Okay. The next test we have to study is the compressive strength test. Now here how many cubes are we going to take is 12 number of cubes. So the side of the cube will be around 50 and again we have to prepare it using the standard lime sand mortar using the ratio of 1:3. Now we have to keep this cubes undisturbed for almost about 72 hours at atmosphere. Whatever is the atmospheric temperature, we have to keep it in that, right? At 90% humidity, we have to make sure that the relative humidity what we are maintaining will be around 90%, and the temperature we will keep is the room temperature, that is 27 plus or minus 2 degree centigrade. Okay. Now all this we have to do it when it is kept in the mold. After doing this process for 72 hours, we have to take out the specimen from the mold and keep it in air for 4 days. After this, what we have to do is we have to take only 6 number of specimens or cubes from water out after 7 days and do the compression test in the compressive testing machine. So this will give us what? This will give us the 14 days strength, and remaining 6 should be queued for about 21 days, and again the test is been determined. Now this will give us the 28 days strength. Again here we have to uniformly increase or steadily increase the load. So we have to start at 0 and increase it at a rate of 150 Newton per minute. So the crushing load, whatever is there, this divided by the area of the cube will give the compressive strength of the motor. Okay, so generally which is at 14 and 28 days. So what we have to do is we have to take the average of the 6 specimens whatever we have. Individually each specimen we have to calculate and finally calculate the average for knowing the final compressive strength of the specimen. Okay, the next last one is understanding the chemical analysis or composition. So generally we have to understand this in order to know what is the cementation and hydraulic property of the lime. So there's one basic formula which we have to understand. So with the help of which we will be able to know the chemical analysis, which is called as the cementation value of lime. This is given by 2.8 capital A plus 1.1 capital B plus 0.7 capital C whole divided by D plus 14E. Now each of them have a different meaning. A is the silica oxide content, which is SiO2. Then B is the aluminium oxide content, which is Al2O3. C is the ferric oxide content, which is Fe2O3. D is calcium oxide content, which is CaO. And finally E is the magnesium oxide content, which is the MgO. If it is present in this proposition, then the lime is said to have a very good cementation value. Okay, so these are about the tests of the cement. I hope the lesson is clear to you. Thank you.